Have you ever gazed up at the night sky and wondered if we are alone in the universe? It's a question that has been asked by humans since time immemorial, sparking curiosity and wonderment. The universe, our cosmic home, is a vast and expansive place. Picture this. It's composed of around 2 trillion galaxies, each of which contains hundreds of billions of stars. Now consider this. Around these stars there could potentially be planets, just like our Earth. And not just a handful of them, but an unimaginable number. Possibly even more than the grains of sand on all the beaches on Earth. Among these planets, there are those that reside in what scientists call the Goldilocks zone, an area around a star where conditions are just right, not too hot, not too cold for life as we know it to exist. These are the planets that could potentially be habitable, and they may number in the billions. Now, with such vast numbers, one might imagine that the universe should be teeming with life, and yet, we have not yet detected any signs of it. This conundrum is known as the Fermi paradox, named after the physicist Enrico Fermi. He asked the question, where is everybody? Given the sheer number of potential civilizations out there, why haven't we received a cosmic hello yet? There are many theories that attempt to answer Fermi's question. Some suggest that life may be common, but intelligent life is rare. Others propose that civilizations might self-destruct before they are able to contact us. And some even speculate that we might be living in a cosmic zoo, being observed by extraterrestrials who choose to remain silent. In the grand cosmic scheme of things, we are but a small speck, looking out into the vastness, listening for a signal that might never come, or perhaps has not come yet. So, are we alone, or is it just that we haven't found our cosmic neighbors yet? In 1961, astronomer Frank Drake came up with a fascinating equation to estimate the number of civilizations in our galaxy. This equation, now known as the Drake equation, is a probabilistic argument that takes into account several factors. Each factor represents a step in the development of a civilization that could communicate across interstellar distances. Let's break it down. The first variable in the Drake equation is the rate of star formation in our galaxy. This is essentially how many new stars are born each year. The second variable is the fraction of those stars that have planetary systems. Not every star has planets orbiting it, so this fraction gives us the number of stars with planets. Next in line is the number of planets that could potentially support life. This is based on factors like the planet's distance from its star, its size, and its composition. But even if a planet could support life, that doesn't guarantee life will emerge. So the next variable is the fraction of planets where life actually evolves. Now we get to the really interesting part. If life does evolve on a planet, what are the chances it develops into a civilization with the ability to communicate across the vastness of space? That's our next factor. And finally, we have to consider the lifespan of such advanced civilizations. After all, if a civilization only lasts a few hundred years before self-destructing or being wiped out by a cosmic catastrophe, the chances of us making contact are significantly reduced. So, there you have it. The Drake equation is a kind of cosmic census, helping us estimate how many neighbors we might have in our galaxy. It's not a precise calculation, but a way to frame our thinking about the likelihood of intelligent life beyond Earth. Despite the uncertainties and assumptions, the Drake equation continues to serve as a scientific tool for framing discussions about the search for extraterrestrial intelligence. Astronomers, with their eyes set on the cosmos, have been relentlessly searching for signs of intelligent life. One of the most notable endeavors in this quest is the search for extraterrestrial intelligence, or SETI. SETI is a collective term for the scientific search for intelligent extraterrestrial life. For decades they've been scanning the skies, listening for signals that could potentially come from other civilizations in the universe. SETI's primary focus is on detecting radio signals. These signals are advantageous because they can traverse vast distances and are less likely to be distorted by cosmic dust or other interstellar material. However, SETI is also interested in other types of signals, such as optical flashes or heat signatures, anything that might indicate the presence of a technologically advanced civilization. But the search isn't simple. Space is incredibly vast, and the number of star systems that could potentially harbor life is staggering. Moreover, the signals SETI is looking for are incredibly faint and easily drowned out by background noise. And even if a signal is detected, determining whether it's from an intelligent source or a natural phenomenon is no easy task. One intriguing incident in SETI's history is the famous WOW signal, received in 1977. This strong, narrowband radio signal was detected by the Big Ear Radio Telescope at Ohio State University. The name WOW comes from the note written by astronomer Jerry R. Eman when he saw the data. Despite numerous attempts, the signal has never been detected again, and its origin remains a mystery. The search for extraterrestrial intelligence is a monumental task, akin to finding a needle in a cosmic haystack. It requires vast amounts of time, dedication, and resources. Despite the challenges, the scientists at SETI press on. While SETI has yet to find definitive proof of extraterrestrial intelligence, their search continues, fueled by our desire to know if we are alone. What if our next-door neighbor in the cosmic neighborhood, Mars, or distant exoplanets hold the key to our quest? As we delve deeper into the universe, we are continually intrigued by the possibilities that other celestial bodies present. Let's take Mars, for instance. This red planet has been a subject of human curiosity and exploration for decades. Mars, much like Earth, has polar ice caps, but it's not just the poles that have caught our attention. Mars has revealed the existence of water on its surface, albeit in the form of ice or briny flows. And where there's water, there could be life, right? This possibility has sparked numerous missions to Mars, including rovers like Perseverance, which are tasked with searching for signs of past microbial life. While we haven't found definitive proof yet, the potential for discovering ancient life forms remains. Now let's cast our gaze beyond our solar system to the myriad of exoplanets orbiting distant stars. Scientists have identified certain regions around stars, known as habitable zones, where conditions might be just right for life as we know it. These are places where a planet is neither too hot nor too cold, enabling the existence of liquid water on its surface. Take the TRAPPIST-1 system, for example, with its 7 Earth-sized planets. 3 of these are located in the star's habitable zone, sparking excitement and speculation about the possibility of alien life forms. The discovery of such exoplanets has led to a surge in research, with scientists using powerful telescopes to study these distant worlds, looking for signs of life, such as the presence of certain gases in their atmospheres. However, it's important to note that while the existence of water is a crucial factor for life as we know it, it doesn't guarantee life. There are many other factors to consider, including the right combination of chemical elements and a stable environment over billions of years. While we've yet to discover life beyond Earth, the pursuit continues, with Mars and distant exoplanets being prime targets. So the question remains, are we alone in the universe? Let's recall the vastness of the cosmos, a seemingly infinite expanse teeming with billions of galaxies, each housing billions of stars. Around these stars, it's probable that there are countless planets, some of which may bear the necessary conditions to support life as we know it. The sheer magnitude of this cosmic arena makes it hard to believe that we're the only intelligent life form in existence. We've also delved into the intricacies of the Drake equation, a mathematical formula that estimates the number of civilizations with which humans could communicate in our galaxy. This equation, while speculative, offers a scientific approach to ponder the potential for extraterrestrial intelligence. It factors in the rate of star formation, the fraction of those stars with planetary systems, the number of planets that could potentially support life, the likelihood of life actually developing, the evolution of intelligent life, and the lifespan of technologically advanced civilizations. We've also touched on the search for extraterrestrial intelligence, or SETI. This ongoing endeavor scans the skies for signs of intelligent life, listening for signals that could indicate the existence of civilizations beyond our own. Despite the vast silence thus far, SETI's search is far from over, and the potential for discovery continues to fuel this endeavor. And let's not forget our exploration of Mars and other exoplanets. These celestial bodies are of particular interest due to their potential for harboring life, or at least, the conditions necessary for life to exist. The ongoing research and exploration of these planets continue to provide us with invaluable insights into the potential for extraterrestrial life. So we circle back to our initial question, are we alone in the universe? The answer is still a mystery, but the search continues. Whether or not we find intelligent life beyond Earth, one thing is certain. Our quest for knowledge and understanding of the universe will continue to push the boundaries of our imagination and scientific exploration.